Let's talk about the barbershop problem here. Here's the barbershop that we have seen here. Now, what is it? It's a barbershop that you can see here. It is a barber, of course, one by barber, along with a barber chair, and we have end chairs for waiting customers. And here are our customers. Now, here's the synchronization in the solution for synchronization problem should satisfy. First, if there are no customers to be served, then the barber should go to sleep. And if the barber is asleep, and when the first customer comes in, he should wake up the barber, and then he should have his haircut. When a customer is having a haircut and the barber is busy, hence a new customer that's coming in should come in, and if there are chairs available, he should come in and then wait and sleep. If all the chairs in the barbershop are occupied, then a customer who's trying to get in should immediately exit. Now let's see how we can solve it. First, let's talk about our the definitions. So we assume that there are n chairs in the shop. We define three semaphores. The first one is a customers semaphore. Okay, we initialize it to 0. A barber semaphore, which is initialized to 0, and then the bus. This essentially keeps track of the number of waiting customers, and barber is the number of waiting barbers. In this case, it's 1 or 0. And then we have a mutex, which is initialized to 1 for mutual exclusion on any shared variable that we have. And then we have an integer, which is counting the number of customers sitting in the chairs. Here we have two threads. We have a single barber thread that's running. It's running in this while true and cut here. And here we have a customer threads, which is can be 0 or more than 0. And in here we have this function that's called get haircut. Now what's essential is when the barber thread is executing its cut here function, there should be at least, and there should be one customer who's executing his get haircut function. That's what we are trying to achieve. So the first thing is, so here we have our constraints, which is if there are no customers to be served, then the barber goes to sleep. So for this, it's easy. In the barber thread, we have this wait customers, which essentially blocks when there are no customers. And so you can imagine that if the shop is empty and the barber thread starts running and there are no customers, so when he does await customers, since it was initialized to 0, then it will block in here. Now in the customer thread, of course, we should have a signal customer such that when the first customer gets in, he should then wake the barber thread. When the barber thread is executing cut here, and then the customer thread then should be executing his get haircut. Now, what about other customers? So for this, what we should do is we should have our customer thread keep track of the number of waiting customers. If the number of waiting customers is less than the chairs, okay, which means that some chairs are available for a customer thread, it increments waiting counter, okay, and then it will then wait for the barber, okay, because he cannot get a haircut immediately. So now since we have this wait barber here, in the barber thread we should also include a signal barber here, such that when the barber is done with his current customer, then he should wake a sleeping customer on this wait and then get his haircut. And after this we decrement waiting counter, we have to get haircut. Now if the number of waiting customers is more than the chairs, then the customer would then immediately exit without getting a haircut. So in here, of course, you can note that the waiting, which is an integer, a shared variable, is essentially a shared variable. So we need to protect this to prevent race conditions. So here we do a wait mutex here, and then when we get in, then we have a signal mutex, and then here again we have a wait mutex and signal mutex here. And note that in this case when I have a wait here, this is coupled in the if and else part. So this is coupled with a signal here, or this is coupled with another signal in the else part. So with this solution, then I highly advise you to check the code, this particular solution or another solution on these sample cases. For example, when the barber, when we initialize it with the barber, it does the barber sleep when there are no customers, and which line. And BC is, does the first customer wake up the sleeping barber and have his haircut? Third, does the second customer, while the first customer is having a haircut, if it comes and when it's wait for the barber, will it wait? Where does it sleep? Which line? Another one is, if I have, five, if n is set to five, and plus one the barber chair, so it means that we can have at most six customers in the barbershop. Does the seventh customer, okay, exit without getting a haircut? And then BCCCC, which means does the barber wake up a waiting customer after finishing the haircut of the first customer? And finally, there are other things like, is the solution efficient? In the case of monitors, do you send more notifications than needed, or do you try to use more semaphores, other variables? So this is also not good practice. Now let's try to solve the same problem with Mesa monitors. So for this, we define a monitor. This is essentially, remember, a class. And we have two conditions, waiting for customers and waiting for barbers. And then here is our counter, which keeps track of the number of waiting customers in the chair. And we have two methods defined within this monitor, a barber and a customer method. Okay. And let me talk about this, what's the corresponding threads that are running. Remember, this is a monitor, and then, this is how we define our threads. Here's my barber thread, and the barber thread runs in this while loop, and it calls this BarberShop, which is the monitor barber, which is this one. And then when it returns from that, then we execute the cut here. The customer thread is simple and it can run in multiple instances. It just calls BarberShop customer, and then within which then it gets a haircut in here. Okay. Now let's look at how it works. So from the barber point of view, it's pretty simple. If not waiting, now this is hold on, since there's at most one barber, this is not needed, but we will be waiting for customers to wait. Else, waiting for barbers to notify, which means that we notify any customers who's waiting for the barber to get a haircut. Now, in the customer thread, our code is again simple. Again, we have this waiting. If it's less than the chairs, then you increment waiting plus plus. If you're the first customer in here, then you send a notify to waiting for customers, which is, remember, the barber is the one who may be waiting for the customer. So this is how it goes. And else, which means that there is already more than one waiting customers, then you just wait for the barbers. Okay, and when you're done, you do a waiting minus minus and then get the haircut. Okay, so that's it. I hope you